Thank you for the opportunity to present our paper at your esteemed conference. I am Abdullah Nasir Choudhury, and I'm going to be presenting our paper titled Performance Analysis of Tesseract and DZOCR for Bangla Optical Character Recognition on the novel Bangla Crosshair dataset. My paper ID is 622, and currently I have written this paper as a research assistant under InteX Research Lab. This is the outline of our paper. Without further ado, let's get into the introduction. So what exactly is OCR? OCR stands for Optical Character Recognition and is the procedure of extracting textual data from images. It's basically used for fraud detection, document digitization, license plate recognition, and forgery detection. And it also finds its application in many other sectors today. So why are we concerned with Bangla OCR? Despite Bangla being the seventh most spoken language uh, in the world, OCR research is limited in this scope. Now, our research focus is basically on performance analysis of two of the major OCR engines titled Tesseract OCR and Easy OCR. So we are going to be delving into PyTesseract, which is a wrapper for Tesseract OCR in this paper. We're going to benchmark on a new dataset, Bangla Crosshair. This is the dataset that we are going to be introducing in this paper. And the metrics that we are using in order to evaluate our OCR engines are word error rate, word accuracy rate, character error rate, character accuracy rate, Levenstein distance, precision recall, and F1 score. Due to time limitations, we are not going to dive into the equations for the evaluation metrics. You can find these in the paper. Related works include a lot when it comes to Bangla OCR. However, when we study the literature, we find that OCR engines are being implemented. However, there's a lack of comparative analysis on the OCR engines. So where exactly is the research gap? So the research gap exists in the limitation that stems from the inavailability of a dataset for Bangla OCR. So this is exactly what we are introducing in this paper. We're introducing a novel OCR dataset titled Bangla Crosshair. The challenges that we faced were lack of a standardized dataset, as I mentioned earlier, and there's always the accuracy versus speed trade-offs when it comes to OCR architectures. So different OCR engines provide different accuracy rates and different speeds, inference speed, which I'm talking about is the metric that I'm talking about here. So our paper also goes through the inference speed. There are existing models which struggle with non-document images such as handwritten images or distorted or noisy Bangla text images. These are also available in our dataset. So this is the methodology. In the Bangla Crosshair dataset, there are 4 folders: Bangla handwritten characters data, Bangla handwritten words data, Bangla text detection and recognition data. These datasets are used for training data. However, we're going to be concerned with only the OCR test data for this paper. So once we have collected the data, we have prepared the data, we are going to be setting up an environment in Kaggle. And from there, we move on to pre-processing the data. Basically, we're going to remove the noise, deblur, enhance, and sharpen the images. We move on and implement the OCR engines, PyTesseract and EasyOCR, in order to extract textual data from the images. And we convert it to structured data in order to perform evaluation. So as I mentioned in the introduction slide, these are the metrics that we are going to be studying. We actually studied in the paper, and and then we move on to reporting the results. Uh, so the dataset is available publicly in this uh, link. If you want, you can take this slide. You can also find the link in the paper. There, as I had mentioned in the previous slide, there are 4 folders, and we're only concerned with the OCR test folder. So here's a sample of the dataset. So A here are blurred images, B here are crisp images, C are tilted images, and D are document images. There's also an instance of torn images. Now there are at the time of the time of creating this research paper, there were exactly 100 total images per category, 20% each category, um, 20 images per category, and 100 total images in the OCR test folder. So all results are available in our GitHub repo, and this is also available in the paper. You can also find our notebooks showing the elaborated results for EasyOCR and Tesseract OCR. We're going to move on to the results and discussion slides. Uh, Basically, the tables that we studied in our paper. So over here, this was an instance of a blurred image, and we find that in several instances, Pytesseract actually underperforms uh, while EasyOCR outperforms Pytesseract, right? So Pytesseract is basically producing 100% order rate or 79.20% order rate, while the bold shows that EasyOCR is outperforming Pytesseract in these cases. So even though the error is okay, so a question might arise: why is the error rate so high? Even though these are state-of-the-art OCR engines. Well, this is because we use these OCR engines out of the box without training them, and basically that was one of the uh, key reasons for our study. We studied the performance of OCR engines without exactly training them. We used them out of the box. So from these tables, we concluded that uh, Pytesseract actually outperforms EasyOCR when it comes to extracting textual data from documents. However, EasyOCR, which is a deep learning architecture, which is an OCR engine based on deep learning architecture, actually outperforms Pytesseract when it comes to challenging instances of extracting textual data from images. This is a tabular summary. Uh, Basically, this table is showing that EasyOCR is outperforming Pytesseract in document images, clear, barred, tilted, and torn images. 1, 2, 3, 4, and 5 actually mean document images, clear images, blurred images, tilted images, and torn images. Yeah, so now we move on to the inference time comparison. So which is faster? Tesseract OCR, even though it does use a deep learning architecture. It's not really highly dependent on the deep learning architecture. And so we see that Tesseract OCR is almost 10 times faster than EasyOCR, while EasyOCR takes much longer time to output images. So what's the trade-off exactly? The trade-off is for much higher inference times, EasyOCR actually produces much higher accuracy than Tesseract OCR. And so in order to and the conclusion would be that EasyOCR excels in accuracy for challenging instances due to its dependence on deep learning architecture, while Pytesseract actually performs the extraction 10 times faster than EasyOCR. These results are reproducible, and all of the code is publicly available in our repository. In a future study, we plan on studying pedal OCR's performance for Bangla OCR under challenging instances. The reason behind not using pedal OCR in our current study is because there's no pre-trained data available. As I had mentioned earlier, we did not train Easy OCR or Pytesseract. We used them right out of the box. So pedal OCR actually didn't have that kind of a capability, and so this was not within the scope. So we plan on training pedal OCR on the training folders, which we made available in our Kaggle repository, in our Kaggle dataset, and then we are going to uh, publish our findings in a future study. And these are the references. These are mainly the references which have been cited in this slide. Thank you for allowing me to present my paper. This is all. Yes, we created this data set, ma'am. It is available on Kaggle. It is available on Kaggle. Yes, ma'am. Yes, ma'am. Mm, exactly, ma'am. Because we lacked a large data set in order to, uh, like fine tune our OCR engines, we did not really train them. However, we are planning on training them in our next paper. We are working on three more folders, as I had mentioned. These three folders: Bangla handwritten characters, Bangla handwritten words, and Bangla text detection and recognition. This folder is basically for documents, and these are handwritten characters and handwritten words. We are planning on adding another instances of images, challenging instances such as blurred images, yes, ma'am, crisp images, tilted, and document images. Just for testing. Yes, ma'am, just for testing. All five categories, ma'am. All five categories. Yes, yes, ma'am. Yes, ma'am. And you can see over here that these are the five categories, ma'am. For we studied their performance for instance. Yes, ma'am. 20 images per category, ma'am. Yes, ma'am, exactly. Okay, ma'am.